Okay, this video is on lines and transversals, and we're going to start out by reviewing a couple of terms that we've already talked about because they're going to be important in this unit. Linear pair angles, which is just angles that are adjacent and supplementary, and vertical angles, which is two non-adjacent angles formed by a pair of intersecting lines. And you can see in this little diagram I've drawn here, we've got linear pair angles. A linear pair might be, for example, angles 1 and 4 or angles 2 and 3. Those are both linear pair angles. And vertical angles we can name here also. Angle 4 and angle 2 are vertical angles, and angle 1 and angle 3 are vertical angles. And those are going to come up again a little bit later. Now we're also going to talk about a couple of postulates. One is called the vertical angles postulate. Vertical angles are congruent. And that's the vertical angles postulate. And as you can see from this diagram here, it's not hard to see that, in fact, angle 1 and angle 3, they are going to be congruent. So we're going to accept that statement as true without proof. And another statement we're going to accept as true without proof is called the intersecting lines postulate. And that postulate just says, if two lines intersect, then every pair of angles formed is either congruent or supplementary. And now again, hopefully that's not too hard to see with this diagram right here. Since every pair of angles in this picture, where I've got these two intersecting lines, since every pair of angles is either a pair of vertical angles, in which case they're going to be congruent, or they're a linear pair of angles, in which case they're going to be supplementary, we can see every single pair of angles has got to be either congruent or supplementary. So for this diagram right here, we could in fact name all of our pairs of vertical angles. So let's see, I've got two pairs of vertical angles here. I've got angle 4 and angle 2. That's one pair of vertical angles. And angle 1 and angle 3. That's another pair of vertical angles. I can also name all of my pairs of supplementary angles. So let's see. Angle 4 and angle 1 are supplementary. Let's see. Angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. And angle 3 and angle 4 are supplementary. Okay, now we're going to talk about lines and transversals. So you see here I've got two lines here that I've labeled L and M. And first I want to talk about the interior and the exterior of these two lines. The interior is just the space inside the two lines. So that would be anything in here in between the two lines. So if I draw some X's in here, in this space here, everywhere those X's are, that's the interior of those two lines, the space in between those two lines. The exterior, that's just the space outside the two lines. And if I draw some, let's say I draw some boxes. So all these boxes, they lie outside the two lines, so all the boxes would be exterior to the two lines. Now, a transversal is just a line that intersects two or more lines. So here I have two lines. Let me draw a third line that intersects these two lines. Let me call this line T. And since this line T intersects these two lines, line T is a transversal. And notice when I draw this transversal here, it creates these angles here. In fact, I'm going to go ahead and label these angles. 1, 2, 3, 4, 5, 6, 7, and 8. So when that transversal cuts those two lines, it creates these 8 angles. And I can also identify each of these 8 angles as being either interior angles, that is, they are inside these two lines, or they're exterior angles, which means they lie outside of the two lines. So let's go ahead and name those. All my interior angles in this figure right here, that's these angles here that are inside the two lines. That's going to be angle 3, angle 4, angle 5, and angle 6. Those are all interior angles. And all of my exterior angles are just 1, 2, and 7, and 8. Angle 1, angle 2, angle 7, and angle 8. Okay, angle pairs. Now you notice that in the previous on the previous board we named several angles, interior angles and exterior angles. Those were all individual angles. Well, now we're going to name some angle pairs. And in particular, these are pairs that have some very specific names. So the first pair of angles we're going to look at is called same side interior angles. And same side interior angles, they have three characteristics. They are on the same side of the transversal. They are interior to the two lines, and they do not form a linear pair. So now, given these three characteristics of same side interior angles, let's see if we can identify the same side interior angle pairs. Remember, we're talking about pairs of angles in this diagram right here. So let's see. They have to be on the same side of the transversal. So let's see. Let's look at the left side first. Same side of the transversal, interior to the two lines. So they have to be inside lines L and M, and they don't form a linear pair. So let's see. Interior to the two lines, same side of the transversal. Well, that's going to be angle 3 and angle 5. Those are same side interior angles. And if we look at the other side of the transversal, interior to the two lines, same side of the transversal, that's going to be angle 4 and angle 6. So those are my only pairs of same side interior angles. All right, so, and you can see where the name comes from, same side. They're on the same side, interior to the two lines. Same side exterior angles, very similar, except in this case we have, they are again on the same side of the transversal. This time they are exterior to the two lines. And again, they do not form a linear pair. Okay, so let's see. Same side of the transversal. So again, we're going to have them, they're either going to be all on the left or all on the right for our pairs of angles. Exterior to the two lines. So let's see. On the left side of the transversal and exterior to the two lines, that's going to be angle 1 and angle 7. That's one pair of same side exterior angles. On the right side of the transversal, I'm going to have angle 2 and angle 8. And those are same side exterior angles on the right side of the transversal. Now notice in these two angle pairs that we've looked at, same side interior angles, same side exterior angles, we didn't really need this third characteristic here that they do not form a linear pair, but we're about to see some examples of angles where we do need that characteristic. So let's take a look at the next type of angle pairs, alternate interior angles. So my alternate interior angles, these, instead of being on the same side of the transversal, they are going to be on alternate sides of the transversal. Alternate meaning or opposite sides of the transversal. They are going to be interior to the two lines. And once again, they do not form a linear pair. Okay, so let's see if we can identify the alternate interior angles on this diagram. All right, so they're going to be on alternate sides of the transversal. So one's going to be on the left side, one's going to be on the right side. Interior to the two lines. So that's going to be these angles here, 3, 4, 5, and 6. And they do not form a linear pair. So let's see, angle 3 and angle 6, that's one pair of alternate interior angles. Another pair is going to be angle 4 and angle 5. They're on alternate sides of the transversal. They are interior to the two lines, and they do not form a linear pair. Now notice, angle 3 and angle 4, those do not form a pair of alternate interior angles because even though they're on alternate sides of the transversal, they're both interior to the two lines. Angle 3 and angle 4 form a linear pair, so that would not, angle 3 and angle 4 would not be a pair of alternate interior angles. All right, alternate exterior angles. Again, they are on alternate sides of the transversal. They are, this time they are exterior to the two lines. And once again, they do not form a linear pair. Okay, so alternate exterior angles, let's see if we can identify them. Alternate sides of the transversal, so again I'm going to have one on the left, one on the right of the transversal. Exterior to the two lines, so all my exterior angles are 1, 2, 7, and 8, and they do not form a linear pair. All right, so let's see, angle 1 is going to form an alternate exterior angle pair with angle 8. Notice they're on alternate sides of the transversal. They are exterior angles, and they do not form a linear pair. So let's see, angle 1 and angle 8, angle 2 and angle 7 form a pair of alternate exterior angles. And once again, let's point out a pair that are on alternate sides of the transversal. See, angle 1 and angle 2, they are not going to be a pair of alternate exterior angles because even though they're on alternate sides of the transversal and they're both external to the two lines, angle 1 and angle 2 form a linear pair, so they would not be an example of alternate exterior angles. Okay, finally, the last type of angle pair that we're going to look at is called corresponding angles. And corresponding angles, they lie on the same side of the transversal. One is on the interior of the two lines, and one is on the exterior of the two lines. And once again, they do not form a linear pair. Okay, so corresponding angles. Now notice, this is the only one that we don't have this kind of matching up with our characteristics here. Alternate interior angles, they kind of, just the name of the angle kind of tells you how to find those angle pairs, how to identify those angle pairs. So corresponding angles are a little bit different. So let's see, on the same side of the transversal, okay, so both of my angles in my corresponding angle pair are going to be either both on the left or both on the right. One interior and one exterior. So let's see, angle 1 and angle 5, that's going to be a pair of corresponding angles. 1 and 5, they're on the same side of the transversal. One is interior, one is exterior. They do not form a linear pair. Let's see, I've also got angle 3 and angle 7. Same side of the transversal, one interior, one exterior. They do not form a linear pair. Now, angle 5 and angle 7, notice that that's another pair of angles that they're on the same side of the transversal. One is interior and one is exterior. However, they're not corresponding angles because they form a linear pair. All right, so those are my corresponding angle pairs on the left side of the transversal. On the right side of the transversal, I've got angle 2 and angle 6, and I've got angle 4 and angle 8. So there are my 4 pairs of corresponding angles. Now down at the bottom of your notes, you've got a little table down there that kind of summarizes all the different types of angle pairs. I want you to go ahead and fill those in. We just named all the special angle pairs in this diagram, but I want you to go ahead and fill in that table, and you can kind of check yourself with each one of the answers that we already provided in the notes. Okay, last thing we're going to do is take a look at some examples. And now in these examples, it says, name each angle pair and the transversal used. So here I've got a slightly more complicated diagram. I've got 4 lines. Here's line L and M, and here's lines R and T, and I've got a total of 16 angles. And it says for each pair of angles, I start out with angle 6 and angle 14, I ask you to give the angle pair name and the transversal. So let's take a look at angle 6 and angle 14. So here's angle 6, and here's angle 14. And now remember back to my definitions of the angle pairs that I just looked at. Angle 6 and angle 14 are corresponding angles. So that's my angle pair name. The transversal, notice that for angle 6 and angle 14, I'm essentially not using this part of the diagram at all. In fact, I could just kind of cover up that part of the diagram, and I would see that angle 6 and angle 14, they're corresponding angles. And in this case, the transversal is line T. So I would say my transversal is line T. My 2 lines are L and M. My transversal is line T. Example number 2, angle 4 and angle 7. So here's angle 4 and here's angle 7. Now this time, I'm not using this bottom part of the diagram. Angle 4 and angle 7 are going to be, let's see, angle 4 and angle 7. Here are my 2 lines, and in this case, line L is my transversal. And so line L is my transversal. Angle 4 and angle 7 are on the same side of the transversal. So they're going to be same side. And let's see, since they are interior to my 2 lines, they're going to be same side interior angles. And my transversal, once again, is line L. Now, I'm going to let you fill in the rest of these examples. And let me give you a tip that on at least one of these examples, there is an angle pair name for them. However, there's not a transversal involved. So I'm going to let you see if you can figure out which of those falls into that category.